the work is being done. We're making the warnings, but it's like, well, they're finally paying heed to it. Not really, just looking at fracking, and it's kind of like too late.
Yeah, the tipping points have been passed, really. And the
I
whole
think so.
COP26 feels like it's too late. Like, and the half measures again. We'll do it in 2040. We'll do it in 2050. Or not even. This net zero is just BS. Yeah, I know we've talked about that. So,
What's the saying? More things change, more to stay the same.
and just like who runs our government, like you said, the oil, they're not gonna want to
No,
change.
of course not. No.
So like
In
what?
fact,
Yeah.
I just completed editing it, and then I realized I had a note to myself. Oh, don't post this video until you post this other videos, and I got to go and edit this other video. But it's a
Oh,
two-part video thing on interactions among tipping elements. That's what how and these researchers are out of Potsdam, Germany, and basically what they're looking at is, okay, so you got Greenland. It does, it melts. How does that affect Antarctica? How does that affect the Amazon? How does that affect AMOC? How does
oh,
AMOC
interesting.
affect? So a lot of the studies that say this is going on. Okay, we see AMOC does this, so they look at it individually. These scientists now trying to look at interactions among all these different things going on, and does it help increase what's happening? No, does it does it amplify the response, or so like a positive feedback loop, or does it mitigate a negative feedback loop, which tends to be corrective in nature? So they're trying to, this is the first of its kind study, and so of course there's going to be some issues and limitation, whatever. Kudos to them for undertaking it. So they're trying to figure out how everything ties together, because Earth is a complex system all tied together. I've got this other set of videos on ocean tipping points that I have to now edit. And this is going to be like 2 45-minute videos. And, these are like some long videos. That's why I had to split it. It's like this, I'm just babbling away too long here. So it's just like,
So there's a part one, part two. Okay, they're
yeah.
coming up.
So this is going to be coming out hopefully in a month or so, because I got a bunch of other things queued up. I've got a series of 3 videos on Antarctica now. I got to queue those up.
Oh my god, you're stacked.
And then I got a couple of things like seabirds and
The seabirds.
algal blooms and fish farming is an interesting one.
The marine species moving north was pretty interesting. That's where I got the climate refugee issue. Even with the animals, they're all climate refugees. Everyone's a damn climate refugee at this point,
Yeah,
or soon to be. I mean, every year going forward is supposedly like harder. Even if you have like a colder year on average, we're still warmer than it's been, which is
it's the old weather versus climate, analogy. It may be cold today, but when you look at the average, the slope is still positive. The
true.
graph may bounce around like this, but you fit the line through it, it's still going up. I mean, look what's happening in the Arctic Ocean right now. You got a couple of ships stuck in the Siberian Sea because the ice suddenly froze.
Oh
Seriously, the
my
sea ice
god.
just went boom. And so now we got icebreakers racing over to free these ships up because they're stuck in the ice. There's like 2 of them that
Oh
way.
my god.
But it's so people say, "Well, so you did blah, blah, blah." I go, "That's it's just an anomaly. It's just a one-off event. So certain conditions that promoted, the Arctic dipole where it shifted, the wind forcing. It's just certain conditions that promoted this. That's all. But when you look at the overall scheme of things, you come back next year at the same time, we probably won't get the ship stuck in the ice." You know?
Well, overall, like the larger trend is we're getting warmer, especially in the Arctic. I mean, the changing ecosystem, but even at the equator, so everywhere's being affected. If you talk about like the
That's right.
link,
And you said a very important thing: the long, long, it's a trending trend, the long-term trend. But that's the important aspect. What's the long-term trend? And long-term trend is we're warming. And here's another interesting thing. Okay, we've talked about how the oceans have absorbed 93% of the CO2 and the heat energy, etc. That 93% is not evenly distributed over the entire ocean. And yes, it's pretty much measured down to about 2,000 meters, but there's more of it. About 60% of that 93% is found in the polar waters. Why is that? Because gas solubility increases with a decrease in water temperature. Tropics are warmer. Not going to dissolve as much gas in the tropical waters as you do in the polar waters. So you're putting that heat more so in the polar waters, and that's going to go into the Arctic Ocean. And you know what? It doesn't even have to be super, super warm. All it has to do is be warmer than minus 1.8 C to melt the ice.
Oh my God. That's like still
It doesn't
freezing.
have to be that much warmer.
Wow, Jim. God, it just goes back to like we're so in trouble. Like every species is in trouble to some extent, right? With this, if the species are moving forward or moving north.
Except cockroaches.
Oh, I know.
Nothing destroys them. I mean, it's just like indestructible.
It's unbelievable. They're like multiplying. Like there's just too many of them, Jim. God.
I mean, but I mean, seriously, because in the Arctic, at least, when the water cools down to about minus 1.8 C, that's typically when the sea ice will start to form. Because, Atlantic Ocean has to be a little colder because of the higher salinity, etc. But about minus 1.8 C is when Arctic sea ice starts to form. So if you bring in water, it doesn't have to be 5 C or 10 C. It can just be 0 C. It will melt that ice. The one I just did about the rain and the permafrost, because that, first of all, is done right here in my backyard. I mean,
Yeah.
as I point out in the video, hey, I'm going to this place. I mean, it's right there. I mean, I know where all these places are. That was part of the study. But the thing is, again, if you instead of having snow as the precipitation, depending, of course, on the time of the year, and it comes down as rain, well, that means right there it's already above freezing.
The
And
permafrost.
then that heat, and it's in the form of sensible heat. That sensible heat works its way through the ground and then starts thawing things out. And then it deepens the thaw layer, which means when you deepen the thaw layer, you then subject more material that can be acted upon by the microbes, which will then release more methane.
But yeah, just what you said. I mean, the urgency or like, warning, like this is a serious situation, and like you said, it's too late. It's so difficult, and like we're like at the end of something, like
at this point, it's almost like, well, we're along for the ride now. Let's see what the hell happens.
and just like our reliance on these fossil fuels, like our society is just so like ingrained. And then like the ratio issue, we said like, oh, we've been destroying the ecosystem for like 180 years, and we're just now starting to talk about, hey, maybe we shouldn't do this anymore.
I was seeing some things saying that even if we reverse blah blah blah, what have you, it would take something like 50 to 70,000 years to like reverse the loss of ice, to bring down the CO2 levels to 250.
God.
I mean, it's just like, yeah, 50, 70,000 years. There ain't gonna be any damn humans left on the planet.
Yeah, that's an astronomical time, and then yet it's no time at all.
Yeah.
I know, it's
Right?
too much. But like that is so interesting. Just the longevity of what we have started